Okay, hello everyone. I think this time actually I was able to remember to start or actually unmute myself. So theoretically I can be heard. And theoretically there's somebody out there listening, and we'll see about that as we go forward, I guess. So yeah, after a week off, I took the past week off because I was getting ready to do a workshop in Spanish and wanted a little bit more time to prepare. But I'm back, and I've got some messing around with functions to do today. I don't know if this will go quite as long as some of them, but yeah, who knows? It might go longer. We can sort of play that by ear, I guess. As usual, as usual, this notebook is going to be on GitHub. There's kind of a pre-flight version there now. And let's see. Oops, that's a mistake. Or I meant to take out the fact that it used to be free, but again, you can find the Quick Python book online at that address for Manning. Again, would love to put in a plug for PyCon 2020 online. That's the link, or you can just go to PyCon 2020 online. And hello, Bruno. Glad to have you here. I've tried to follow in your footsteps and smooth things out a little bit since the first one. So there's that. The other thing that I wanted to announce was the upcoming PSF board elections. And hello, Chuck. Glad to see you. So this is something, having been on the board for years, that it's always kind of a frustration. And that is that the people who vote for the PSF, Python Software Foundation Board of Directors, tend to largely come from North America and Northern Europe. And consequently, they vote for a lot of people from North America and Northern Europe. And the only way we can change that is to get more people voting from other places. At least I think that will help quite a bit. So the way to do that is anybody who is giving volunteer hours of 5 or more volunteer hours a month is able to become a contributing member of the PSF and vote. All you need to do is go and follow a little bit of a procedure there to self-certify that you're giving that much time. And I guess it's just my opinion, but I think that even if what you're doing is doing online communities, as we all have to do these days, as in hosting a regular stream like this one or any of those, I think that counts as well. So I certainly would encourage people to go ahead and think about doing that. My good friend Carolini Dantas has actually done some guides, tutorials for how to sign up for a membership. So if you get confused on the python.org website, you don't know how to sign up, you can be stepped through. We kind of work together so that we've got English, Spanish, and Brazilian Portuguese, although I notice right now I got the links crossed. So let me actually switch those around. So let's move this one up here and then get that one there. So you can check those out. And of course, if you have any problems or any questions at all, you can feel free to ask me, and all of that is just fine. That still looks wrong here. Let me fix that one more thing. Let's give ourselves a little space. There, that'll be better. So yeah, I do want to put a plug in for that. And Chuck, if you want to do that, I think we would love to have that as well. And I haven't yet talked to Eva and Betsy about whether they want to put something like this on an official site. But I was going to do some tweets, sort of publicizing these resources and things like that. Because I think particularly if you're not terribly used to kind of the weirdness of some of the things on the PSF pages, it can be a little bit confusing what you need to do. I'd also say, particularly for people who maybe aren't the most comfortable in English, figuring out those forms is sometimes a little bit daunting. But, you know, again, the steps are: first, you become a free basic member on the site. If you aren't that already, that's really easy. Then you go find the Google form and self-certify, and then they add you as a voting member and you get a ballot. And I know in talking to Betsy, there were a few people that did it yesterday. And like I say, if we want different representation, we need to have different voters. So this is the place I recommend we start. Okay, well, so that's kind of our start here. And like I say, anybody wants to do that at all, let me know. And Chuck, if you want to do something with a Chinese translation, like ping me outside of this and we'll figure it out. I think that's great. So I wanted to play around with functions a little bit today. And as always, I encourage people to experiment. Part of what I'm going for in doing these sessions is to just show how it is I go about fooling around and experimenting a little bit. So oh, you can see my dog just left. She's bored. So I encourage people to play around, but I do want to say that most of this is exploring and poking and prodding at how the language works. This isn't necessarily meant to be modeling things that you would do in production. There are some things that, yes, you could do in production, but a lot of this stuff, you know, check and get some other resources rather than, oh, just I saw Naomi do this thing, I'm going to stick it into production. Be careful about that, because again, that's not our purpose. We're just gonna goof around. So talking about functions, we said in past sessions that functions are objects. Everything's an object, so functions are objects. That's fine, but then we talked a couple of times ago about creating instances. We talked about creating classes. So, you know, the first thing we're going to do is talk a little bit about creating functions, which is obvious, but people don't think about the underlying stuff too much. And then we're going to consider how functions as objects behave. So let me switch over to my more coding window here. All right, got that going. And we can then kind of consider what we've got. So functions are objects, definitely. And they are created when their code is first executed. And there I'm making a distinction. When their code is first executed, that's not the first time they're called, but the first time the code making up the function is actually executed. That's usually, if it's in a file, if it's in a module or in a program, that's usually when it's loaded, because all of the code in a Python module or file is executed when it's loaded. Or if we're in the shell, or in this case in a Jupyter Notebook cell, then it's kind of when we get to the end of that and execute that whole thing. So that's when a function is created and becomes an object. And as we're going to look at, this is just kind of the preliminary stuff. Functions can be assigned variables. So that is something that's quite often handy. They do have attributes just the same way that other objects have attributes. And since they are objects, they can be function parameters and function return values. So that's some of the stuff that I want to play with here first. Of course, as you have any questions, feel free to put those in or any comments, and we can kind of explore or pivot if needed to play around with that. This one, I will admit, is certainly a little bit more free form than some of the other ones. I've got a bunch of stuff that I kind of want to do, but if you want to do something else, maybe we can do that too. Kind of depends. So here, let's talk about a function. This is a function that I called myfunc. Not terribly original. It's got a doc string. It takes two parameters, and it adds those two parameters and gets a result, then it returns the result. So when I actually execute that cell, it becomes an object, right? So I can do this, and it says, hey, I got a function, and its type, its class, if you will, is function, and here's its name, here's its signature. Yeah, we got a function. Okay, and does the function work? Well, yeah, it works. Okay, and if we look at it, we can see here that, if we use the ID, and remember last time we were using ID as just a way to get the unique identifier for Python objects. So when I ask for myfunc's ID, I get it, which is as it should be. It's not particularly shocking. And then again, if I want to assign it to a variable, like if I want to say myfunc is your func, I can do that. So I can assign that here. And then I can use the new name to call it. Okay, so I can do that. It works. And as we can see, it's got the same ID, so it is the same object. Okay, that's all, what should I say, kind of stating the obvious. If you've done much Python at all, this shouldn't be terribly shocking. Okay, this is all pretty much standard stuff. And again, from what we've done in talking about objects and all of that. Oh, you're right. Thank you, Chuck. There. I missed that totally, but you are quite right. It should be the same thing. Thankfully, it doesn't change anything, which is good news. Yeah, and so yeah, this is all kind of the straightforward standard stuff. Now, the other thing that I kind of want to mention, well, actually, before that, why don't we take a tiny detour, because it just occurred to me something that would be interesting to mention. And that is, I don't think I've talked about this here. People who come from languages like C and Java and things like that sometimes complain that Python doesn't have an equivalent to the switch statement, where you can actually, rather than doing a long, complicated else-if ladder, you can instead just have this one structure that can make several choices for you. And in fact, as some people will tell you, the way you can get around this in Python is to have make a dictionary. So we could do def func1, and I'm going to just make these be very simple, and they probably would all just do pass, because I want to just illustrate this really fast. So these functions do absolutely nothing. They're only here so that I can have a bunch of functions really fast. If I would have thought of this earlier, I might have made something prettier, but hey, what can you do? then what you can do is you can do something like, I don't know, let's call it and we can make a dictionary, and we can say if the user enters a 1, we're going to match that up with func1. And if they enter a 2, we're going to match it up with func2. And if they enter a 3, we're going to, excuse me, a 3, we're going to match that up with func3. And then we can do something where we say, I don't know, in this case, the result's always going to be none because these are do-nothing functions, but we could say select function. That's what I called it. There we go. And we'll say x equals, and I'm just going to make this a comment. Voice, and in this particular case, I'm going to say 2, but it would be normally something you get from the user at x, and then we call that. And this won't do anything, of course. And Chuck's looking out for me. Mind the space. I think I've got it okay now. Yeah. So when we do that, it's, oh, that space. Thank you. I should have listened. There we go. So there, yeah. And it would do that, and it would let you then do a multiple selection. If you want to have a default thing, you can always have use a .get on this dictionary of function objects. There are different ways you can do it, but basically the fact that functions are just objects in this particular case means that we can pass them around and put them in a dictionary and then use dictionary keys to select which function we want to do. So we don't really necessarily need to have a switch statement. Yeah, I cut my teeth programming on switch statements, and it would, I was very, very used to them. But in fact, this trick in some ways is a little bit slicker, in my opinion. So in any case, that's my detour on how it is we don't need a switch statement, because in Python functions are objects and we have dictionaries. Okay, so at this point, I want to just take a little detour and say, okay, functions have attributes, so let's look at what attributes they've got. And we've got a longer list of attributes than we would have in just a garden variety class that inherits from object. This is true. And there are a few of them that I'll just kind of point out, some of which we're going to talk about, and some of which we may not have time to get to today, depends. So notice we got something called annotations. That's for type annotations. We might have a peek at that. We've got something called call. That's going to be important. We got closure, which I don't want to get into today. We've got a code attribute. It's probably important. We've got a defaults. We've got a globals. That's not usually something you get. We got a KW defaults. That's a little bit different. We got a name and a qual name, and there are a few others there that you wouldn't find in just garden variety object, but we do have a number of things here. And we also have, by the way, a doc attribute, which all objects have. And so if we look at that, as you would expect, it gets the doc string that we defined back up here. This is my function. Okay, cool. So, so we've got that. And in fact, this is something that will be important in a second here. Scroll, scroll, scroll. There we go. machine is not the most responsive. Um, the guys on my team would say it's because I have about 5,000 windows open, but don't listen to them. Okay, so we can do this. We can, with a function, as we could with other objects, we can set the docstring after the fact. So if I want to say, instead of this being my function, this is really your function, I can do that. So let's fire that off. And yeah, it fell for it. Now notice we've got a name attribute. And here, just for the sake of our argument, remember I'd set my func and your func are both pointing to the same function object. So I'm going to change a couple of these just for fun. So they're the same object, and it's like, okay, so even though that's the variable label that's pointing to it, the object itself was defined with the name myfunct, because that's what we said when we went def, blah, blah, blah. And then this attribute also is something that can be changed. So there, and I'm going to leave this one myfunct, because remember, these are two labels pointing to the same thing. And just sort of fire that off and illustrate, see, yeah, that all worked. So you can actually then reach in and see things like that. And the things that people are most often concerned with, particularly if you're writing some tool where you want to do documentation or a little bit of introspection, you probably kind of start with things like name and docstring. And there are other things that we can go into, but that's just like a starting point. It kind of works the same way. So, yeah. Now, we're talking about functions can be parameters. So here, I've defined a function for functions, which I imaginatively call funct. Well, it wasn't imaginative, I was just being silly last night. And all it does is print out what it gets. So it doesn't have to be a funct, it could be anything, but just for the sake of argument, to pass it in, that's what we're going to do, just so that we've got something. Now, if I take the function we've already defined and use it as a parameter to funct, it should print out just the sort of function signature that we see back up here. Like, I don't know where the heck it is all the way back, like something like that. Okay, something similar. It'll be a little bit different because we're printing rather than just showing it in the REPL, but it'll be similar to that. Okay, now this, since I kind of already said it's something we can do, it's probably not a huge thing to have people speculate, but if anybody thinks this will be a syntax error or something, please speak up. In some languages, definitely it would be a syntax error. But in Python, I'm going to spoil the surprise. It really shouldn't be a syntax error. Well, let's see. I mean, there's always the possibility that I screwed up somewhere, so we'll see. Okay, so it does that. As I say, it's not exactly the same thing, but it's pretty close. Object of type function, it's called myfunct, and it's at blah, blah, blah. So there. Which kind of tells us that even this messing with name up here didn't actually change this part. That's in another attribute. So there are lots and lots of things that you can tinker with here. Okay, again, in terms of what you would do in production on a day-to-day basis, you probably don't want to tinker with a lot of this stuff. But again, if you're looking to understand all of the bits and pieces and how they fit together, then by all means, let's sort of poke at it and see what happens. So that's what we're doing. Okay, then here, sorry for the spelling error. The other thing, though, is that functions can be return values. So here, again, different languages have different rules, and as the language develops, even the rules change a little bit. But here, I've got a function that I just decided to call func because I was being silly last night. But it's a function that creates and returns a function. Okay? So this nesting of functions, any thoughts? Is that legal? Does this strike anybody as being weird? Ah, yes, Chuck, you can see where I'm going. It is very funkety. Yeah, it's pretty much the same thing. So basically, inside of func, we make a new func, and new func's job is to print whatever it gets as its parameter. But we don't call this function here. We execute the code and create the object here and return it. So looking at this, we can do that. Okay, it executes. That's cool. And then like, okay, let's see what this object is. Yeah, it's a function. That's not a shock. Okay, now what about new func? Can I do that? Any thoughts? Or what will happen when I press Shift Enter and execute this cell? Exactly. It's not global. I didn't say that at all. So when I do that, it's going to say, nah, can't find it. On the other hand, suppose I do this. Test equals, and I'm going to call func. And then I'm going to execute what I get. I'm going to actually call what I get. Okay? This is a different thing. And yeah, Zach, the other one was just out of scope. And without actually calling the function, there's no way to get it in any scope other than the local scope of the function. And this is kind of an interesting thing. If you cannot get at anything, then it's eligible for garbage collection. So up here with new func, if I don't actually call this, any new func that is created is not going to exist for very long. It'll be created and then thrown away. So, but here, if I actually pass it out, that means I get basically a reference to the function I created inside. So that means it does have a handle to it in scope, and it will persist even after this is all closed out and gone away. And in fact, that's really important for things like decorators and things like that, the fact that we have this behavior. So if there's a reference to it outside of the function, which will happen when we return it and assign it to a variable, then it's going to hang around. So that means if I do this, okay, like Chuck said, it doesn't have a parameter because func doesn't take a parameter. What it creates takes a parameter when it's called, but we're going to execute it first and then call it. So right here, we can do this, and the function that we get here does work. Okay, and when we look at it, it's a function, and notice that sort of, what should I say, its signature indicates not that it was created in main, but that it was created inside of func and was local there until we passed it out. Okay, so that's a little bit freaky, but let's just look at this again. So we can do the ID on this, and notice it's like do this. All right, now let's call the exact same function again and get another object. Now my question is, and this is one to think about a second, when I do ID on the object I get here, is it going to be the same as the one I got the first call, or is it going to be different? And I am going to pause a little bit and let people consider this. Okay. Zach knows me too well. He thinks it's going to be different. Bet is it's different. Okay, well, let's reason about it a little bit before we actually test it out, although testing it out is pretty easy. But if every time if a function is created when this code is executed, excuse me, these two lines are executed, then it stands to reason that every time we execute the code, we're going to create an object. So it should definitely be different. And it is, in fact. So yes, that this all works. And notice, actually, one other thing we can do here, just to kind of poke at this a little bit, we can look at test dunder name, and it's going to be new funct. And we can look at test2 dunder name, and it's going to be new funct. So their attributes are going to be pretty much the same because the same code is firing every time to create them. But they are going to be technically different objects. So the func is created when we first made that function, absolutely right. But then the object inside of it, the function that we created inside of it, each time that code fires, that is, each time we call func, yes, we're going to get a new function object. It's going to be functionally identical, no pun intended, but it's not going to be exactly the same object. Okay, and if you think about this and start throwing in things about how default parameters and stuff like that works, it's all kind of the same sort of behavior. Is there a way to find the name of func from test or whatever? Well, the one thing that you can do is just get its whole signature. So up here, basically, we can tell that's where it was created. I think you can also, as you dig around in some of the other function attributes, I think you can also find out that way. But off the top of my head, I don't remember which attribute that would be. But yes, certainly if you're doing introspection, that information is available. As I say, if nothing else, it's here in the function signature. So even from here, you can tell where it comes from. So yeah, definitely. Okay, so functions are objects. Therefore, they can be parameters and return values for other functions, yes. And if something like a function is created inside another function, as long as that thing that's created inside ends up with a reference in the outside world, it will be able to live on after that code is executed, which is what we saw here with these, with test and test2. Since they're passed out and we have a reference to those objects, they live on, they're not garbage collected, they don't go out of scope. All right. Now, this is what I know Chuck's been thinking about the whole time, is decorators. So decorators are, in effect, they're I'd say a syntactic sugar, a convenient way of wrapping one function in another function and taking advantage of the things that we've seen so far. Okay. Now, there are some things to consider that I want to show you as we work through those, but let's just actually look at this. So, suppose, again, you know me now, when I do this, I like to pick really simple examples so that I don't think about the problem, I think about the machinery. So I've got here a function that takes two parameters and adds them together and returns the result. That's all it does. And of course, there would be all sorts of times where there would be parameters we wouldn't want to add together. So I'm going to, in this case, decide that I want to only add integers. Now, I could add a bunch of code to make sure inside this function that there were only integers. But if I wanted to do that on a whole bunch of things, I would end up having to repeat a lot of that code, which would be hard to maintain. Or I could make a function that I would run everything through in advance to check, and I could do that. That would still be a little bit clunky because I'd have to do a function call every time to make sure they were right. So instead, what I can do is I can actually wrap my function for adding inside a larger function that will create a wrapper that does the checks. Okay, now here, basically require int is in a way a function factory, a function creation thing. Its main task is to create a wrapper around another function and make sure that before we call that function, we check to make sure that both arguments are integers. Okay? This is not, by the way, something you should ever do in production. Don't do it exactly this way, because for one thing, you should never use assert to check types in production code. Because if you run the Python interpreter with the $O flag for optimize, all assert statements go away. They don't even get compiled. They just disappear. So, you probably wouldn't ever put this in production code. This is just a way that I could make the checks real fast to illustrate the point. And there are some other things about this particular definition I've got with arg1 and arg2 specified and things like that that also aren't ideal. So not a production example, but a quick way to see if this works. So require int is something that creates a wrapper that checks parameters and then calls the original thing that was given to it. And when that wrapper has been created, remember when this block of code is executed, as soon as it's executed, we have a function object that wrapper is pointing to. So once this is created, we return it so that we can use it. So here I've defined add. Then down here is where I do this bit of silliness. So what I say is I want to call the require int function, which is, remember, a wrapper function creator, with my add function that I just made. And it's going to wrap it up in the check to see that they're both ints and return it back. And I'm going to store that under the same name as add. Okay. This means, by the way, that I will no longer be able to directly access just this function. Instead, I'm always going to have to go through this thing that I created. Okay? Now, this is obviously a little bit silly looking, but does it work? Well, let's see here. There we go. Execute. Thank you. It works. And let's actually do a check or two and see if it does its job. So let's see. I'm going to make this into a string. We should get an assertion error. We get an assertion error. It's doing its job. I'm going to make it 3.0. What do you think? This should also catch it. Yep, it catches it because an int is there. So yeah. And of course we go back to the other thing. Yeah, we're fine. Okay. I guess, it's like I said, there were some other things that weren't really ideal. The fact here that I'm specifying we only have 2 arguments and kind of spelling out those arguments is also something that you probably really wouldn't want to do if you were writing a wrapper that you're going to use more often. So more often when you're writing a wrapper, you'd use something like maybe the star args to get just the whatever arguments are passed as a list, and then I could do my check just using indexes into that list and then return it back the same way. This would mean you could use it with functions that took more than 1 or more than 2. It wouldn't have to have an exact match. You could use require int to wrap functions that took different numbers of parameters, as long as whatever you did in here was okay. So this would be kind of a more common way of doing it, and this works exactly the same way. So there's really not much difference here, other than this is just something that you'll see quite a bit. So just so you've seen it. Okay, now that's not the way that we do decorators in Python, of course. In Python, instead of doing this step, once we have this function defined, we can instead use this decorator. Like I say, syntactic sugar. It's a shortcut for expressing it. So doing this is in effect the same as doing this. If I just do @require int, I don't have to explicitly do this. And this was added quite some time ago. It makes things a lot easier when you have it in code. I mean, it's not, in my opinion, it's not the most easy thing to read when you have function signatures with a bunch of decorators, but it's even squirrelier if you have to do this in various places. So this right before the function thing is the way that you do it. And of course you can stack these. Like if this one turns its result, you can put another one up above it and it would, basically wrap whatever came below. So you can stack these and do various things with it. But this is the basic idea. And if you need to do more parameters, you can specify parameters and things like that too. So this should be the same thing as what's up above. And it is. It works exactly the same way. But I want to show you what happens here when we do this. So when we've got, and actually let me add a doc string here. we've got this here. And I want to print out the function's name on the way in. And let's print out the docstring as well, just to be sure. So I want to illustrate what we get here before we do any wrapping. So I got that, and yeah, let's do that. Okay, now we should know what the function's name is on the way in. And it is, it's add. Oh, wait, I screwed up here. Let me actually put this here. There. And we got the docstring. And in response to your comment, Chuck, yes, it's good for testing, is handy using decorators. It's also used a lot in things to do things like enforcing, say, authentication in web frameworks. Like if somebody's going to hit the get method, you can decorate it with something like requires auth or whatever, and it will only do it if the right things are there. So yeah, decorators are useful for a lot of things because they let us basically abstract some of the like machinery and helper type functions off into a place where we don't need to worry about them, but it's still pretty easy to understand that they're being called into the action. So again, we got add, we got here. All right, now my question is, oops, I don't want to do that. I want to get rid of that. If I do the same thing here, I'm going to put this in here as well. And I'm going to call, and it should be after. Okay, so now I'm ready, but now after we do the wrapping and I print out the name and docstring for my add function, what's it going to say? It's going to be changed. I agree. Any thoughts on what it's going to be? Okay, I'm not seeing, okay. The name is going to be wrapper. Let's go ahead and confirm that. And in fact, the name is going to be wrapper and it won't have a docstring. And in fact, if we were to use this require_int function to do it on a whole bunch of other functions, we wanted to wrap a ton of different things, their name property would always be wrapper, and their docstring would always be none. Okay, in other words, by doing this wrapping, we have thrown away a whole bunch of introspection information. We can no longer go and see what was going on with this. So what do we do about that? Well, so it turns out, as I'm sure you're aware of, that there is a functools library that is there to help write better and more interesting functions. It's got a number of different things. It's got the LRU_cache function, which is a way to automatically add caching without having to think about it. It's got a whole bunch of stuff. So it does have, in fact, a decorator that helps you make decorators. And this decorator is called @wraps. And @wraps is something that uses a couple of other things from the FuncTools library, partial and update wrapper, combines them in a way that basically lets us not lose that information. And what it does, and actually let me go get my stuff here. I want to grab this so that I do this all the same way. Okay, let me go up here and grab the other one. Adding the doc string is a nice touch. I should have done it before, so I'm going to put it up here. And I'm I've got my doc string there. Yep. Okay. So now if I do it, basically the function will now get its, I should say, the function wrapper that we created will now be updated to reflect its the attributes of the thing that it is wrapping. Okay, so if I do this, it's going to, you see, I actually need to give it the name of the function so that it's able to grab that stuff. But if I do this, that means this object is going to have its metadata updated so that it looks like the original. And what I mean by that is here. So func name before the decorator add, func name after the decorator add, docstring, docstring. All of those attributes are the same. You can actually, I don't know how easy it is to do using the wraps decorator, but I do know that the update wrapper function from FuncTools will let you control which things you either make a copy of and which things you just directly point to the version in the original. So like in this particular case, the doc string gets updated so that this doc string is actually pointing to exactly the same string object. It's not even just doing a copy, it's just actually updated. And yes, it does do type annotations as well, so that if you want to do that, you get the same thing. So yeah, I didn't put that in here, but we can go ahead and add a window and see. So like, let's see. So adds, oh, not adds, add, sorry. There we go. Does have the same annotations before. So that gets copied. You don't lose stuff. As I say, you can do, and this, by the way, will work not only on an actual function object, but if you've got a class that's callable, the update wrapper thing, you want to wrap it, will work the same way too. So it's actually kind of handy. And when you do this, your resulting object ends up being, ends up having, I should say, an additional attribute called wrapped. And what wrapped is the original function that is being wrapped. So inside your wrapper, you do have a way that you can actually grab and get to your original function. So, you know, if I wanted to do this, that should work just fine. And, you know, this one now no longer has my checking. This is the original one, type error, because you can't add those two. So you can actually get at the original function that you wrapped up. It's kind of cool. And then, oh, we want the code object, add code. It's got, we're going to talk about this in a second if we have time. So, we're already going longer than I expected, except in a way I expected it, because I always just tend to go on in these. One thing that I wanted to talk about really fast is what makes a function a function. That is, what makes it something we can use like a function. Because you can do all sorts of things, but, like for example, I can make some function that takes 3 parameters and it'll work. But the thing that really makes it work is the fact that it's got this dunder call method. Okay? So if it's a call, we can call it. Of course, if I do this, it's going to say, oh, no, you can't do that because you're missing parameters. So I can say, oh, sorry, let me give you the right parameters. And that's actually just the same as if I were to do just plain old up here, some func, well, excuse me, 1, 2, 2, 3, same thing. So in effect, this is the thing that actually gets fired when we call it. That's cool. And of course, if we make just a regular garden variety object and we try to call it, we're going to say it's not callable. And all that is another way of saying we don't have a dunder call. So suppose we gave our mystery class a dunder call attribute. In fact, suppose we just decided to glue a function onto it and say, yes, going forward, your dunder call method is going to be this function. Is this going to work? So yeah, yes, I mean, you can make anything a function. Yeah, why not? Well, yeah, I mean, that's right. So we're going to do this. Well, it lets us do that. So now I'm gonna call this with 1, 2, 3. Do you think that'll work? Okay. We got one taker already. All right. Well, I'm gonna give it a try. Let's see. It says some func takes 3 positional arguments, but 4 were given. But wait a second. 1, 2, 3. Any thoughts there? Self? Yes, because we've attached it as a bound method, which we poked at 2 or 3 times ago, it's going to get self automatically. And if we print this out, since all that this function does is print out its parameters, we can see this. So yes. So it's basically, this is self. It's a mystery object that blah, blah, blah. And these are the other parameters that we gave it. Okay, and we could, and you can see that, like our mystery object, well, that's the class. Get out of here. I don't even want to talk about that. Not helpful. Other than the fact that it now has a dunder call method. But what about code? Not ready for that either. So we go here. But if we do, what I want to do is this, I think. Yes. So there we go. We print this out. We can see we don't have nearly the number of attributes that an actual function does. We can now call it. We can now execute it because we've got it under call. But we don't have any of the other stuff. We don't have a name. We don't have defaults. We don't have tons of other stuff. So we just got part of it. And in fact, we can do the other thing here too as well. And so we can make another class where we just manually define a dunder call method. And it's going to work the same way. That is, if we give it 2 parameters, it's going to think it's got, self as the first parameter, then 1, then 2. So that's what we got. And I think, we're getting towards the end. I wanted to show you one last thing which is another interesting attribute of function objects. So function objects are callable, but they also have a code object that is attached. So right now I'm going to do some real simple stuff, but one thing I'm going to do, this is a tool that I haven't really talked about in any previous times, but it's kind of handy when you start poking around, and that is the Python disassembler. So the Python disassembler takes a code object, like a function or like a class or a method in a class, and disassembles it into its bytecodes and what they do. So I'm going to do that, and I'm going to make a real simple function here that does very little. And I'm going to then disassemble that object. So just so you can see how this goes. What's your problem? Oh, it's not foo, it's funk. I've decided not to use foo anymore in my function names because it's just too much of a cliche and I don't think it helps. So this is the actual code in terms of bytecodes that are generated. So we get a bunch of different things here. So we get a command to load the print function. There we go. And it's load global because it's not part of our function. It's just something that's out there in the overall world of the interpreter. And then we can call load fast, which means it's local. In this case, it came in as a parameter. And we're going to load our two parameters, whatever they might be, but they're in A and B. And then we're going to call the function that we referenced up here in slot 2. Or rather, we're going to load that function, call that function. And then we're going to load a none, and we're going to return none because we don't have a return value. So if you stare at the disassembly for a while, particularly in manageable bytes, manageable chunks, you can kind of see what's going on, and it's kind of helpful sometimes as you're picking things apart. So wanted to show you that. The other thing, though, is that dis has another function that's kind of handy, and that is it will do this show code thing. So what show code does is you give it a function, will actually tell you a little bit about what's going on. So it'll tell you the function's name. It'll tell you the file it's in. Okay, so right now we're in the IPython shell, so that's a little bit bizarre looking. It will tell you its number of arguments, which is correct. Number of keyword-only arguments. We don't have any keyword-only arguments. Number of locals. Well, the parameters A and B count as locals to the function. So, you know, those particular A and Bs are not going to be accessible anywhere else. The stack size, some flags, none of those are particularly interesting. We don't have any constants other than the none that gets returned, and names that are called is print, and then variable names in this particular function, A and B. And in fact, if you look at some of the attributes for this function, we'll be able to see those. And so, again, we've kind of done this. I'm going to block that. So in fact, if we do a dir funct, again, it's the same thing. We get some various things. Name we've looked at. We do have a defaults here, and I want to look at that in a second. So let me uncomment that so we can see defaults. So we do have one default value. So this is the way a function keeps track of it. Remember up here we said that we have one value for a default. So this list of defaults is the actual objects that will be used in order for the function's defaults. You know, we've got a name. We've seen that before. We've got this code thing again, which is the object that actually contains the compiled bytecode. So if I do this and just look at the func code, as opposed to up here I did it on the whole function, you're going to see that it's actually pretty much the same thing. So I'm going to hide that. I'm going to do this. And you'll see it's the same thing even though I'm now looking just at the code object. This is the part that we really care about. And if we look at that code object, we'll see, again, no foo, it's func. I changed that at the last second. There we go. We've got a bunch of stuff here that looks kind of object-y normal, and then we got a whole bunch of this stuff. So we got an arg count, we got cell vars, we got code, we got constants, we got file name, first line number, flags, keyword only count, name, names, non-local, stack size, var names. So I got a bunch of stuff in here. But the code object, code object itself is the same thing we saw before. Okay. And then we've got some other things. So like here, if we look at arg count, this is how the function knows it needs 2 arguments. So when we actually get into running that code, how is it Python knows to tell you you're wrong if you don't have enough arguments? It checks this. And if we want to introspect and see what variables are used, what var names are used inside the function, we can do var names. Again, this names thing that we got before is here, and it says, yeah, we call the external print function. We can look at the number of non-locals, things that are defined outside that we're supposed to access. So just a whole bunch of stuff that we can look at in here. So that actually takes us plenty of time. Any other things that people want to ask about or that we need to poke at? Because I think this is about where I'm going to stop with sort of my spiel. So any questions or anything? Oh, thanks, Chuck. I'm glad you liked it. Okay, well, not hearing any, or not seeing, I guess, any questions. I think it's about at the point where I'll switch over to the bye-bye screen and mute the microphone. And in answer, yes, Chuck, I'm planning on continuing this. I'm got a bunch of things that I can work through. And to be honest, I'm sort of working on a project proposal with my publisher, so it helps me to actually do those. So my plan is that I will be doing another one next week. I haven't decided exactly what I was going to do. It might be messing around with lists and things like that. Not sure. Certainly open for suggestions to see if there's something that anybody else is really interested in. You can always, like, ping me on Twitter. You can put it in the chat here. Do the suggestion box down below on Twitch, whatever. By the way, I will eventually move these over for archiving purposes to YouTube. So it'll probably take me a day or two before I do that, but those will be up there. Okay, well, like I say, I'm going to switch over then to the end screen. And thanks for stopping by. And yes, I'll be doing something and doing the usual tweets to announce and all of that. So there will be another one coming up next week. So thanks, everybody, and bye-bye.